Alright guys, welcome back to Underground Science. In this video, we're going to start talking about functional groups. So the first functional group we can start talking about are the basic functional groups that we've been actually practicing naming all this time. So the first one we can mention are alkanes. So this is an alkane, but specifically it's butane because it's 4 carbons long and it's an alkane. And that's basically it. So this is the first functional group. The next one we can talk about are alkenes. So if I were to draw this, but I add a double bond in, now this becomes an alkene. Specifically, this is butene. And if we're being even more specific, at what carbon number is the double bond on? That would be the carbon number 2. So this would be 2-butene. All right, if we keep on going to alkynes, right? So alkynes, if we did this, that would be an alkyne because it's a triple bond, and it's a 4 carbon long chain, so this would be butene. And specifically the functional group would be alkyne. And then what if we drew this? That would be propane, right? So this would be an alkane functional group. But what if we drew this? Now this is a new functional group because to make it shorter, we can always refer to this as the parent chain, and this is the true functional group that makes up this parent chain. So this parent chain we can always designate as R. Okay, so if someone drew this, right, that would be an alcohol functional group because there's an alcohol group. OH is an alcohol group. So we just went through another functional group, which is an alcohol group. Next, if we're still focusing on oxygens, I could also draw this. What would this functional group be? So if we have a double bond to an O and a single bond to an OH off the same carbon, this functional group is called a carboxylic acid group. All right, and then of course this part right here will be designated as R. So you can also draw this like that. This would also be a carboxylic acid functional group. A fun fact about this is if we drew this structure right here, specifically the carbon chain is 2 carbons long, 1, 2, and then we have the carboxylic acid functional group. So we're going to go into naming these common functional groups later in later videos, but for right now, remember the prefix eth means 2 carbons, right? And this is 1, 2 carbons, and then to name carboxylic acids, you finish it off like this. It would be ethanoic acid. So whenever you see the suffix oic, you can probably tell that this compound is a carboxylic acid, right? So whenever you see oic, okay, try to think of a carboxylic acid. Eth indicates 2 carbons, so ethanoic acid because it's a carboxylic acid. Now, you can also name this molecule acetic acid. Okay, both names are right. Fun fact though is that acetic acid, this molecule right here, is a big component of vinegar. All right, now that we went over carboxylic acids, let's stay on carbon double bond oxygens, right? So if I drew this, right, parent chain, and then I do a double bond right here, and another hydrocarbon chain. So for example, if I do something like this, basically, a simple version, what would you guys call this? This functional group where you have a carbon chain here, and then let's fix that bond, carbon chain here, and a double bond to this carbon, right? This is a ketone functional group. And in the same way, we can review another one right here, is if we drew this, but instead of another R, instead if it was an H, this would be an aldehyde functional group. So aldehydes and ketones, you can remember together. Ketones, you have two carbon chains, right, on each side. But for aldehydes, you only have a carbon chain here, and then you have an O, C double bond O, and a C single bond to an H. And if we keep on talking about ketones, if we drew an example, let's say I drew something like this, right? You can also refer to this group as a carbonyl group. Okay, so you can say, okay, look at this carbonyl group, but if you were talking about functional groups, this would be a ketone, right? Because technically, this is R, and then this right here is also R, but since it's a different number carbon chain, we can say R prime. So this would be similar to this structure then, right? Because if we said R prime here, or it doesn't have to be, it can be the same R group, right? This is 1 carbon long right here, 1 carbon long, right? So this is a methyl substituent, or a methyl group, 2 methyl groups on each side, or it can be 2 different carbon chains on each side. So we learned carbonyl, ketones, and aldehydes in this slide. If we keep on going and stick with C double bond O functional groups, there's also another one we should be familiar with, which looks something like this, right? So let's say there's R and R here, right? So some hydrocarbon chain, or any carbon chain basically, that's why we designate it with R. You can even make it different chains by doing R prime here. This functional group right here, the main part to focus on though would be right here, and that would be an ester group. So this kind of looks similar to a carboxylic acid group, right? Because a carboxylic acid functional group looks something like this, but you had an H here, not bound. So this oxygen in a carboxylic acid, this oxygen right here is bound to a hydrogen, right? But in ester, this oxygen is bound to some carbon chain, R. Okay, and also another thing to know is that esters, they have a fruity smell. Okay, so if you're ever in a lab doing a reaction or something and you are trying to do, or you're trying to convert, and we'll go into reactions later, but you can convert a carboxylic acid into an ester. And if you do that and you start smelling a fruity smell, right, you can know, okay, I'm getting some esters in the product. So esters have a fruity smell. Next, since we're talking about our esters and carboxylic acids, so if we go review carboxylic acid again, right, if someone showed you this, you would know, okay, this is a carboxylic acid functional group, specifically this part, right? But what if I drew this? So now this kind of looks like a carboxylic acid group, right? The only difference is that this carbon here was I said the answer, this was a carbon. This atom right here was a carbon. However, here it's replaced with sulfur. So instead of calling it a carboxylic acid, we're going to say a sulfonic acid group. So that won't be too hard to remember because it sounds similar. So this is a sulfonic acid group. All right, and similarly, if we look at the structure of a ketone functional group, it was something like that, right? But what if we, instead of these oxygen, what if we replace that with a sulfur? So what if our new structure was something like that? Now, instead of saying this is a ketone, this would be called a thioketone. Because usually when you hear some thio, right, like thiosulfate or thioketone or thioether, that would indicate a sulfur atom. Staying on the topic of sulfur, right, if we were to draw this, put an SH at the end, remember we said the prefix of sulfur would most likely be a thio, right? Something thio. Once you see thio, you can know there's a sulfur that you're working with. So this can also be drawn like this. This functional group with an SH at the end of this carbon chain is called a thiol functional group. Okay, and if we remember that when we're drawing esters, we're drawing something like this, right? And so instead of this oxygen atom, what if we put a sulfur atom? So let's erase that and put a sulfur atom. Now originally we would call, if this was an oxygen, right, we would call this an ester. But because we put a sulfur, right, remember the prefix was anything with a sulfur would most likely be thio. So we can call this, instead of an ester, we can call this instead of an ester, we can call this a thioester functional group. All right, so this right here specifically would be a thioester functional group, while this one right here would be a thiol functional group. All right, so if we keep on going, right, if we're talking about oxygens again, one functional group we can mention is this, right? So if you see anything like that, or it can be any number or any carbon number on each side of the oxygen. So this could be like a 3 carbon chain, a 2 carbon chain. If it's different carbon chains on each side, you want to designate that. If you're writing it in this R configuration, you can write it as R prime and R right here, so they can know, person reading this can know that, okay, there's 2 different carbon chain lengths on each side of the oxygen. But if we're talking about in general, this functional group right here is called an ether functional group. And similarly, right, if we drew that again up top here, small, but instead of this oxygen, if I drew this, right? So instead of this, if we drew this, instead of an ether, this would be a thioether group. All right, so this would be a thioether group, specifically this one right here. And then if someone asked you what this functional group was, this would be an ether functional group, like we did last slide. And also, when we're doing reactions, right, or if you're doing reactions in a lab, ether is often used as solvents because ethers are mostly unreactive. All right, so ethers are relatively unreactive, and that's why they're really good to use in solvents when you're doing chemical reactions in a lab or something. All right, let's move on to another one. So let's talk about nitrogen-containing functional groups. So if we start with the most simple one, that would be an amine. So if we drew something like this and drew some hydrogens over here, like that, so this would be an amine functional group. All right, and something about amines is that they have a fishy odor to them. Fishy odor. Okay, so now that we know what an amine looks like, if we even did if we went over a small example of this, right, a real life example, drew something like this, right? So we'll go into naming these common functional groups in future videos, but for now, what we know so far is that this is 3 carbons long, right? Before the nitrogen, there's 3 carbons, so the prefix we'd use is prop. So you would just say that this molecule is named propyl because it's 3 carbons long, and then what's this functional group? It's an amine functional group, so the name for this would be propylamine. And so this is just an example of an amine functional group. Now, another thing we should know, right, that'll be useful in future videos when we're talking about reactions, is that this molecule right here, if we drew 3 hydrogens with a lone pair of electrons on nitrogen, this would be called ammonia. And then if this ammonia gains a proton, right, because ammonia is a base, okay, ammonia is a base. So if this base, and what do we know from our general chem playlist, is that bases accept hydrogen protons, right? So if this base, ammonia, accepted a hydrogen proton and looked something like this, then this would be called ammonium. All right, so those are just nitrogen-containing groups that we should be familiar with. Another one is the amide group. So not amine, but amide. And so if we drew what that looked like, an example would be something like this, where you have a C double bond O and then a single bond to the N, right? And then the N is also bound to atoms. This would be an amide functional group. And this is really important when it comes to peptide bonds. So these are peptide bonds, are bonds that basically link amino acids together. So these are bonds that link amino acids together. Okay, so what is this functional group called? This is an amide functional group. All right, and we'll go over peptide bond formation and all that later. Because we're talking about nitrogen-containing functional groups, we should also be familiar with this functional group right here. So if I do something like this, right, this functional group, a C triple bond N, is called a nitrile functional group. Okay, so nitrile. So if we drew a actual carbon chain, right, an actual carbon chain for the R, if we saw something like this and a triple bond to an N atom, so this right here would be an example, specifically this part. So remember, this is an imaginary carbon here because it's a line diagram. So specifically, this would be a nitrile functional group. All right, so that's nitrile. And if we look at another functional group that has nitrogen in it, so let's draw that over here. So it would be an R group here, attached to a carbon, double bond to an oxygen. Then this carbon is bound to a nitrogen. This nitrogen is bound to another R group. And then this nitrogen again comes off, binds to a carbon, double bond to an oxygen, and then bound to an R group. Right, so this right here is called an imide functional group. Not amide, but an imide. All right, and similarly, if we looked at another functional group that sounds similar to imide, I mean, it's not really, it's an imine functional group. So let's write that down, an imine functional group. Imine looks something like this. Basically, an imine is just a carbon double bound to a nitrogen. Okay, so if we drew this carbon right here, double bond to a nitrogen, this nitrogen can be bound to whatever, like a R group, let's say, and then we bind this carbon to another R group. This right here specifically though, right here, this is what makes this an imine functional group. All right, so that's that. And also, if we know imines, we should know enamines. So an enamine looks something like this. If we drew an example of it, it looks something like that, double bound to a nitrogen here. This can be bound to whatever, and this carbon, let's say, is bound to another carbon. So right here, this is an enamine because, so let's write that down first. So N and then amine. So N, this right here, this first part of the name, N, right? So remember enes, if you see ene or alkene, that would indicate double bond. So this ene right here, N, right, is this double bond right here. And then off this double bond, we have an amine branch. So that's why it's called an enamine functional group. All right, so moving on, if we looked at this functional group right here, so these are also important in reactions that we'll talk about later. Right, if we looked at this functional group right here that has a bunch of nitrogens in it, so let's say we drew this right here in the lone pairs like that, right here, this one would be called an azide functional group. And this will be also important when we do, again, like I said, reactions in the future. But it's important to know these now, so when we do the reactions, it's not, these functional groups aren't completely new to us. All right, so another thing we forgot to talk about when we're talking about oxygens, right, oxygen-containing functional groups, are epoxides. So it looks kind of like like we're about to draw a cyclopropane ring, but instead we put an oxygen here instead of a carbon and do that and connect the oxygen and the carbon with a bond. If you want, you can draw bonds here, but in general, this is right here, right? So if you ever see this part, that's indicated as an epoxide functional group. All right, and this is also important because there's epoxide opening reactions that we can go over later when we talk about reactions involving epoxide functional groups. All right, so those are epoxides. And another thing we can talk about is when we looked at this functional group right here, this we said was a carboxylic acid functional group, right? So again, this was a carboxylic acid functional group. And I'm emphasizing acid because of this acid functional group, right? Because carboxylic acids are acidic, so they're lower than normal pH. And so if we're talking about something similar, if I drew this, but instead of drawing an OH, I drew a chloride group, right? This would be called an acid chloride. All right, so you can see it's similar structure to carboxylic acids, but instead of the OH, we have a chloride. So that's why it's called an acid chloride group. All right, moving on to rings. Right, so we know alkanes, so if we drew this, this would be a cycloalkane functional group, right? Specifically though, this would be a cyclohexane ring because it's 6 carbons long. Similarly, because we already know what an alkene looks like, right? So if we drew that in ring format, something like this would be a cycloalkene functional group. Specifically, we can call this a cyclohexene functional group since it's 6 carbons long, has a double bond, and it's in cyclic format. And then sticking with cyclic compounds, a really important functional that we should know looks like this. So if you notice, there's 3 double bonds, okay, and this would be called a benzene functional group, a benzene ring, okay? This whole thing's called a benzene ring. You can also see this referred to as an aromatic ring. These are really important when we talk about reactions again in the future. Something I remember that we should talk about when we're talking about sulfur groups, right? So when we drew this, what did we say this functional group was right here? This was a thiol functional group, right? But what can happen is in proteins, specifically the tertiary structure, right, you can get disulfide bonds. And we'll go over amino acids later, but you can get something called disulfide bonds which looks like this. And so this is called a disulfide bond. So let's go and write that down. A disulfide bond. And these disulfide bonds are really important in keeping the tertiary structure of proteins. So that's something cool to know. These are really important in keeping the tertiary structure of proteins. And we'll talk about all this when we talk in our biochem playlist, when we talk about amino acids, peptide bond formation, and all the structures of like primary, secondary, tertiary, quaternary structures of proteins. All right, so going back to talking about benzene. So what did we say benzene looks like? Benzene looks like this, right? something cool that we should know also that's actually going to be common, right, when we talk about reactions is this structure right here. So this right here would be called a phenol ring, okay, because the OH makes the ol suffix, right? So if you see the ol suffix somewhere, just highlight that in a different color. Ol indicates an alcohol group. Okay, so this would be a phenol group, or a phenol compound. We should also be familiar with this functional group right here. So if I drew something like this, this would be called an alkyl chloride, right? Or if I drew something like this would be called an alkyl bromide, right? So you get the point, alkyl bromide. So in general, these functional groups are called alkyl halides, all right? Because chlorine and bromine, right, are halogens. So we call these alkyl halides because this is the alkyl chain, right, hydrocarbon chain, and then off the chain we have a halogen substituent, so it's an alkyl halide. All right, a few more we should be familiar with is if we're talking about oxygen containing functional groups again, if you see this will also be important when we talk about reactions in the future, right? So this would be called an anhydride functional group, anhydride. Or you can also see this called as an acid, so or acid anhydride functional group. All right, a few more functional groups to go that will be useful for us when we encounter reactions in the future. So another functional group that we should know is the cyanate functional group. And so that would look like this. And if we know this functional group, so we said this was the cyanate functional group, and another similar functional group to this, a similar looking one, will be something like that. So we replace the oxygen with the sulfur, and now this would be a thiocyanate. Since when you see the prefix thio, you should know, okay, is there a sulfur anywhere here? And speaking of sulfurs, right, if we looked at, so if we remember back to this functional group, we said this was the sulfonic acid functional group. And if we drew something else that looked like this, but instead of drawing an OH off the sulfur, we drew another R group, this would be called a sulfoxide functional group. And we may encounter this as an example. This would be dimethyl sulfoxide because this part right here makes the sulfoxide functional group, and then you have two methyls coming off the sulfur, so that would be dimethyl sulfoxide. And this will be important when we talk about, again, reactions that involve reagents such as dimethyl sulfoxide and other important molecules. All right, last functional group that we should know and we'll talk about is this one right here. So if we drew this, these two oxygens right here make up the peroxide functional group. Okay, so this functional group is called the peroxide functional group. And you guys may have heard of this molecule right here, which is hydrogen peroxide, right, which will be important in future reactions. And particularly though, like we mentioned, this group right here, the oxygen bound to oxygen, makes up the peroxide functional group in hydrogen peroxide. So this is what makes up the peroxide functional group. So the functional groups in this video, right, were like the main functional groups that we should know for future reactions. Maybe some of them were like not that unique or not that common, but overall, if we're familiar with the functional groups talked about in this video, we should be good to go on recognizing these functional groups when we talk about reactions in the future. All right, so I'll see you guys in my future videos where we'll start talking about reactions.